Hi, my name is Stephen McGee and I'm the author of Health Forensics. And we're here to look into the grounding system of the home and what happens to it when you put capacitive filters onto the electrical system. And these capacitors are 47 microfarads each, and there's 8 of them, and we have them split up between two circuits. This is live 1, and we have 4 capacitors on this system, and it's currently switched off. And over here, this is live 2, and we have another 4 capacitors that are currently switched off on this side. And in America you have 2 live connections, and between those 2 live connections there's 240 volts, but we have these capacitors connected in on the 120 volt circuit of each of the 2 lives. And currently there are no capacitors connected on the circuit, and this is our waveform. So I'm going to put down the video camera and we're going to switch on a bank of capacitors. And just to let you know what we're looking at, so the red waveform, that's the 120 volts, and the yellow waveform is the grounding system as referenced to a non-electrified ground rod in my back garden. And the scale right now on the yellow channel is 200 millivolts per square in the vertical direction, and the time base is 5 milliseconds in the horizontal direction. And the red channel is reading 50 volts per division in the vertical direction. So now we've got a basis for what we're looking at. Let's switch on a bank of 4 capacitors. So that's what the waveform on the grounding system looks like when we have 4 capacitors connected to it. So I'm going to switch on the other 4 that is on the other live connection. So we're back to looking like something that we started out with. So you can see that they actually changed the waveform. So I'm going to switch off the original first bank that we started with and see what happens. So you can see we've got the distortion back with just 1 bank of capacitors on the system. I'm going to turn off that bank. Okay, so no capacitors are on the system. And now I'm going to switch them on at the same time and we can see what happens with that waveform. So here goes. So there's not really that much of a change when you put both banks of capacitors on live 1 and live 2 at the same time. So what we're going to do now is we're going to look at a function called the fast Fourier transform function, or FFT, and it allows us to look at the frequencies. So this is the frequencies on the system, and it's 250 Hertz per division in the horizontal direction and 20 decibels per division in the vertical direction. And we have the capacitors on. So what I'm going to do, I'm going to turn both sets of capacitors off and watch the spikes for the change. Okay, they just went off. As you can see, the spikes change. So the first spike on the left, that's the fundamental harmonic, and every other spike going out from that is an odd harmonic of that fundamental 60 Hertz frequency. So I'm going to turn on 1 bank of capacitors. So that's 1 bank on. I'm now going to turn on the other bank. And as you can see, it actually changes the amount of harmonics that you have on the system. I thought it was very, very interesting that these capacitors are actually changing what's on the grounding system. So I'm going to turn off the first bank. So the first bank is now off. I'm going to turn off the second bank. Okay, so the second bank is off, so we have no capacitance. So that's my findings with putting capacitance on live 1 and live 2 and what it does to the grounding system. I hope you enjoyed the presentation and I wish you the very best of health. Thank you.